Hello there, this is an Algebra 1 video. It is Chapter 9, Section 2, and today we will be discussing solving quadratic equations by the method of graphing. And remember that a quadratic equation is in the form ax squared plus bx plus c if it's in standard form. And in this case, because we are solving the quadratic equation, we're going to equate it to 0. That's equivalent to saying that it's the y-coordinate. Normally you have y equals ax squared plus bx plus c, and we've basically replaced that y with a 0. And so if you replace y with a 0, it means that you're in essence looking for the x-intercepts of the graph. So when it's asking for solutions, one of the words or terms that is synonymous with solution is x-intercept. And so you're trying to find the place on the graph where the on the coordinate plane, where the graph crosses the x-axis. And so there are three possible scenarios of quadratics. You can have the scenario where you have two unique real solutions, and that's when the parabola can clearly cross the x-axis in two unique spots. It doesn't have to be a parabola that's right side up. It could be upside down and crossing in two unique spots. So you could have two unique real solutions. But it's also possible for you to have the graph only cross in one unique spot. So you can see here the vertex of the parabola, sorry about that, the vertex of the parabola is basically touching the x-axis. I don't know why it's doing that, but I'm just trying to draw a vertex there. Okay, so when the vertex touches the x-axis but doesn't actually cross, so then in that case you're only going to have one unique real solution. And then of course it's possible that the parabola not intersect at all on the x-axis, and in that case you would have no real solutions. And so those are the three scenarios. So we're going to get started here, and we know that to graph a quadratic we have our method of doing this from the previous lesson. So I'm going to be using that method, and the first thing I want to do is find the vertex, and x equals negative b over 2a, and in this case my b value is negative 2 and my a value is positive 1. So the two negatives here make this a positive 2 over 2, which is 1. So the x-coordinate of the vertex is going to be 1, and my y-coordinate is going to be 1 squared minus 2 times 1 minus 8. So that's going to equal 1 minus 2 minus 8, and 1 minus 2 is negative 1, and negative 1 minus 8 is going to give you negative 9. So my vertex is going to be x1 and y negative 9. Alrighty, so then what you want to do is pick a couple of points to the right or to the left. So after 1 comes 2 and before 1 is 0. So we're going to plug 0 into our equation, and when you plug 0 in, you're going to get negative 8. Sorry, I'm trying to double check this little guy here. And 2 will also be negative 8 because of the symmetry that we learned from the previous lesson. So now what I'm going to do is I'm going to come over here and I'm going to graph this little guy. So 0, 2, 4, 6, 8, 0, negative 8 right there. 1, negative 9, we're going by ones here, so 1, 2, 4, 6, 8, negative 9 will be right about there. And then 2, negative 8 is going to be right here because of symmetry. So you're going to get a graph that looks like this. And like that. Hold on, let me see here. Trying to get this little guy. Just like that. So I graphed my parabola, and now we're asking for the x-intercept. So basically at this point, once you've graphed it, you kind of want to look at the graph and see where does the graph cross the x-axis, and it does so here, it appears, and also here. And those values happen to be x equals -2 and also 1, 2, 3, x equals 4. So those would be our solutions for example 1. Our solutions would be -2 and 4. And you can also check that by plugging the -2 and the 4 back into the equation and confirming that you in fact get 0. So -2 squared is positive 4. -2 times -2 is positive 4. So 4 and 4 is 8, minus 8, and you get 0. So the -2 works. 4 squared is 16. -2 times 4 is -8. So 16 minus 8 is 8, and then 8 minus 8 is 0. So they both do work, so I've checked my solution, and there you go. That's how you solve by graphing. You basically graph the parabola, and then find the places where it crosses the x-axis. And don't forget to always check your answer, because if you draw the graph incorrectly, it won't cross in the right spot. So you want to make sure that you make your graph as accurate as possible. You can also use a calculator to confirm your results as well. So here's your do-it-yourself question, part A, and here's your part B. I wanted you to have enough space to do all the work that you needed to do. And now here we have example 2. In example 2, we're going to go with our first example was a situation where it crossed in 2 spots. In example 2, we're going to have a situation where it doesn't cross in 2 spots. And we call this a double root, and we'll see why. First thing we have to do is put this in standard form. So standard form would be x squared minus 6x, and bring the 9 to the other side, so plus 9 equal to 0. And then we're going to go with our vertex. We want to find our vertex. So it's going to be x equals -b over 2a. B in this case is -6, a is 1. So the two negatives there make this positive 6 divided by 2. So you're going to get 3 for the x coordinate of the vertex. And for the y coordinate, we're going to get 3 squared minus 6 times 3 plus 9. So 3 squared is 9. 6 times 3 is 18. So 9 minus 18 is going to give you -9 plus 9, so we get 0. So when x is 3, y is 0, so we're going to have our t-table. X is 3, y is 0. And because the y-coordinate is 0, this is basically the x-intercept. And when we think about a parabola, this is the vertex, so it's either the lowest or the highest point of the graph. But to confirm, we can say 2 is before 3 and 4 is after. So when we plug in 2, you're going to get 2 squared is going to be 4. Sorry, we're going to plug it in here. We're going to get 2 squared minus 6 times 2 plus 9. So 2 squared is going to be 4. Minus 6 times 2 is 12. And 4 minus 12 is -8. And then plus 9 is going to be 1. So we're going to get 2, 1, and 4, 1. So in this case, when we graph our parabola, we're going to have 2, 1. So there's 1, 2, 1. And then we have 3, 0. And 4, 1. And you can see what I mean by the fact that this graph is not going to go beyond or turn around again, and so it only crosses the x-axis one time. So our solution, for example 2, is that x equals 3. And when the graph touches and doesn't cross, and it kind of does this little thing where it kind of sits on the x-axis, we call that a double root. And that's because if you had it, you probably didn't notice, but this quadratic is actually a square of a binomial. If you were to factor it, you would get x and x to get x squared, and 3 would be 3. 3 times 3 would be 9, and if they were both negative, you would get -3 and -3x to get -6x. So basically, this quadratic is the same thing as x minus 3 quantity squared. And basically what that tells us is, when we're trying to solve for the algebraically, is that you're going to get the same answer twice, because when you solve x minus 3 equals 0, you're going to get x equals 3. And you're going to get that same answer twice. So basically what we call this is a double root. And when you have a double root, this is what the graph looks like. Just a tidbit of information there for you. Alright, so now we're going to have you try part A, and then part B, and then we'll move on to example 3. So we've done the 2 unique solutions. We did 1 unique solution. Now we're going to do a scenario where you have no real solutions. Okay, but we're going to do it the same way that we have been in the past. We're going to say x equals, this one's already in standard form, so x equals negative b over 2a, and the b value is negative 3, and the a value is 2. The two negatives here are going to make this a positive 3. 2 times 2 is 4, so this time our y coordinate, or sorry, our x coordinate for the vertex is going to be a fraction, but that's okay. We can handle fractions as long as you have your calculator handy. It'll make it easier for you. To get our y value, we're going to get 2 times 3/4 squared minus 3 times 3/4 plus 5. So 3/4 squared is going to be 9/16. And then 9/16 times 2 is going to give us 9/8. And then 3 times 3 is going to be 9/4 plus 5. So we take our 9/8 and subtract 9/4. And that'll give us negative 9/8, because we're going to have to times this by 2, and the 9 by 2 is going to be 18, so 9 minus 18 is negative 9/8. And then we're going to add 5, and again, this will all be done on your calculator if you don't like fractions, which a lot of you don't. But at the end of the day, we get 31/8. So for our vertex, we're going to have x is 3/4 and y is 31/8. And I'm going to go ahead and put 0 here because 0 is an easy number to work with. And since 0 and 3/4 is 3/4 away, if I add another 3/4 to the 3/4 there, we're going to get 1/2. 3/2 are not 1/2. Okay, so when I plug in 0, I'm going to get 5, and so this will be 5. So now we're going to come over here and graph our parabola. 0, 5, so here's 0, we're going to be going by 2s here, 2, 4, or actually it's 1, 2, 3, 4, 5, 6, 7, 8, okay, so this is 0, 5, and then we have 1.5, 5, so that's, here's 1, here's 2, 1.5, 5, and then the last one is 3/4 is basically 0.75, so here's 1, so it's going to be right about here, and then 31/8 is basically 3.8, so almost 4. So this is 1/2, this is 3/4, so almost 4, that's 1, 2, 3, there's 4, so a little below. And then we have our graph that looks like this. Alright, and so you can see that what happens with this graph is that it doesn't even go anywhere near the x-axis, so you're not going to have any x-intercepts. And because there are no x-intercepts for this guy, we have no solutions for our equation. So we can use that symbol to indicate that there are no solutions. All right, so now we're going to go on to example, sorry, this is your do-it-yourself part A, do-it-yourself part B. And then I've skipped example 4 because it seemed a little bit redundant. But we're going to do example 5. And for example 5, you're going to want to use your calculator. So make sure that you have it handy. It says here, a goalie kicks a soccer ball with an upward velocity of 65 feet per second, and her foot meets the ball 1 foot off the ground. The quadratic function h equals negative 16t squared, which is standard for gravity, plus 65t, so the 65 comes from the upward velocity that was given, and then the plus 1 is the initial height, which was 1 foot off the ground. So this equation was given to you in this case. I just want you guys to be clear that the upward velocity goes here, and the distance off the ground goes here. And that's important because in the do-it-yourself question, you're going to have to include those values for yourself. The problem's going to change a little bit, but I want you to know how to get those values. So this function represents the height of the ball in h in feet after t seconds. So h represents the height, and t is for seconds, so time. Approximately how long is the ball in the air? Well, what we're going to do is we're going to graph the function, but we're going to ask you to graph it on the calculator, so we're not going to see a whole lot here. You can see the graph in your book on page 557, but I want to tell you what the steps are for you to do that. First thing you want to do is go to your y equals, and then type in the equation. Remember that the t that you can see here is basically like the variable. So you can use the x variable button on the calculator. So I'm going to put negative 16 and then x instead of t because the calculator only has the x as a variable. So the variable button is right here next to the alpha key. It says x, t, theta, n. It basically has all those letters because it means that this button can replace any variable that you have in your problem, including x, t, and n and theta. So go ahead and put negative 16, use that button for the variable button. So x squared, and then we're going to go plus 65x, and then plus 1, and then you hit enter, and then you want to go to your window. Don't hit graph just yet because your window is going to be all off, and if you don't fix the window, you won't see what you want to see. So I'm going to tell you right now that you're going to want to go from negative 4 on the x-axis. So when it says x minimum, type in negative 4 and hit enter. And then where you see x maximum, you want to type in 7 and then hit enter. And where it says x scale, just go ahead and leave that alone and just leave it as a 1. It should already say 1. And hit enter, go to the y minimum. And for your y minimum, you want to go to negative 10. And then for your maximum, you want to go all the way to 70 because this is a 65. It's a pretty big number. So you want to go all the way up to 70. And this time for your scale, you want to go by 10. So instead of going 1, 2, 3, all the way to 70, you're going to go 10, 20, 30, 40, 50, all the way to 70. All right, so your y scale, sorry, is going to be by 10. So once you've done all that, now you can go ahead and hit the graph button. And then you will see a graph. And it will look, let's see if I can turn my pen back on. It's going to look something like, here's going to be 70, and it's going to look something like this. All right? Just briefly, okay? It's going to be really close to 70, but really it's more like 66. But anywho, so what I want you to do right now is the vertex of this function is negative b over 2a. So it's going to be negative 65 divided by negative 32 because 2 times 16 is 32. So negative 65 divided by negative 32 is basically 2. It's approximately 2. When you plug this function, this number into the equation to find out the height, you're going to get negative 16 times your answer squared plus 65 times my answer plus 1. The y value is approximately 199. Oops, I'm sorry. It's not negative 199. I forgot to put negative in my answer there. So I'm going to plug the 2 back in. It's going to be negative 16 times the answer squared plus 65 times my answer plus 1. So you're going to get approximately 67, okay, which is what you're seeing here. It's not quite 70, but again, I just wanted you to have a rough estimate of what the graph looked like. And so what I want you to do now is I'm going to give you some steps for how to find this value. We want to see how long is the ball in the air. So this is basically the trajectory of the ball. So the ball starts here at 0 feet from the ground, and then it goes all the way up and it comes back to the ground. So you want to figure out how much time has elapsed here. It looks like it's starting at 0, 0. So because of that, we want to make sure that we figure out what this value is, and that'll tell us how far it was in the air. So what you want to do is I'm going to write the steps on the board, or I'm going to write the buttons that you need to push. So you're going to start with the second. You have to be looking at the graph. You want to go second and then trace, the trace button. And then you're going to want to go to intersect, which is option 5. And when you go to option 5, you're going to see a series of questions on your screen. It says first curve. And so what it wants to do, I'm sorry, you don't want option 5. That's the wrong option. I'm totally sorry about that. You want to do second trace, and you actually want to find 0. You want option 2. Sorry. Thinking of a different class. You want option 2 where it says 0, and then it's going to ask you left bound, right bound. So what you want to do is make sure that the cursor is blinking somewhere to the left of where it crosses. So like for example right now, mine's blinking right here. You'll see the cursor is just blinking. This value is before the actual place where it crosses. So the calculator is going to basically take this value here. So when you hit enter, your calculator is going to put an arrow saying that it's going to start from here this direction, and then it's going to say right bound. So you want to move your cursor until after you've passed the x-axis. So now it's blinking down here somewhere, and it's going to put my other arrow this direction. So I hit enter, and now I should have 2 arrows that are kind of facing each other, and if I were to draw imaginary vertical lines from those arrows, then the x-intercept would be in between them. Okay, so that's the idea. And then the last question is guess. At that point, you're telling the calculator that it's okay for it to guess what the answer is. So you hit enter one last time, and it says that the x value is approximately 4.078. All right, and that's in seconds, okay? So when it says how long is the ball in the air, approximately 4 seconds it has spent in the air. All right, so now we're going to ask you to do this do-it-yourself question, and once you have completed this example, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.